Hello YouTube. In today's video, I want to give a brief introduction to what Scilab is and compare it a bit to MATLAB. So if you're an engineer or someone who works in academia and you find yourself doing a lot of math a lot of the time, then you're probably familiar with something called MATLAB. MATLAB is an engineering software precisely tailored for engineers and scientists alike. It's a programming language and it's very popular among academia. It's used for all sorts of things like creating programs, running simulations, and generally even creating apps. So here in the first slide you see it says brief introduction to Scilab. In this video I want to touch upon what Scilab is compared to MATLAB and Simulink, and finally I will touch upon the graphical editor in Scilab, which is Xcos. Xcos is Scilab's version of Simulink. We'll talk about that later. So, first of all, what is Scilab? Scilab is an open source alternative to MATLAB. So if you know MATLAB, you'll probably be very familiar with Scilab because it's very similar to it. It's a numerical computation software as opposed to symbolic computation. Numerical computation is when you do stuff like deal with very big data, with matrices. We simulate a lot of physical phenomena. You have to solve differential equations, and many of these differential equations are not solvable analytically. So if you did math in high school, or if you went to college, most of the maths you've done before is probably symbolic. It's when you're given an equation, you're told to solve for x, or maybe you're told to prove something, to come up with a formula, to generalize a concept. That's all symbolic math. And if you know about software called MathCAD, for example, that specializes in symbolic math. But Scilab and MATLAB are both numerical computation software, meaning they're mainly useful for numerical computation. If you're majored in engineering, you've probably taken a course called numerical methods. In it, you probably use some methods to, for example, solve derivatives numerically, solve integration numerically for integrals that cannot be analytically solved, and things like that, or solving differential equations numerically. That is the area Scilab specializes in. And finally, Scilab is, of course, a high-level programming language for technical computing. So just like Python or C or any other programming language out there, Scilab is also a programming language, but the difference is, unlike Python, it is precisely tailored for specific fields of study like science and engineering. Python is very wide and broad. I mean, you can do most of all Scilab has, and even more with Python, but Python is very broad. There's very wide range of applications, so you have to download and install specific libraries to do specific stuff. For example, for symbolic computation, you have to download a library called SymPy. For numerical computation, there is NumPy, and so on. However, Scilab comes with many built-in functions. As it says here, it includes over 2,000 built-in functions for various applications, and it's cross-platform compatible, meaning it will run on Windows, Linux, macOS, any operating system that you already have. And it's open source. This is a major boon that Scilab has over MATLAB. Scilab is accessible for free. You can download it from their official websites, whereas MATLAB is a proprietary software. You have to pay a lot of money to be able to use it. Now, in the next section, I'd like to compare a bit MATLAB and Simulink. So if you already are using MATLAB, why should you even consider Scilab? So if you don't know already, MATLAB is a powerful numerical computation environment. It's widely used for algorithm development, data visualization, and simulation. Like I said before, it's very popular. You can find lots of tutorials on MATLAB and Simulink online. It has an extensive library of pre-built functions, just like I said for Scilab, and it is seamlessly integrable with Simulink. Simulink is MATLAB's graphical editor. It's an intuitive graphical interface. If you've worked on Simulink before, you know what I mean. It's very simple to use. Instead of the traditional code-based programming that you do by writing code on the keyboard, on Simulink, you just drag and drop some blocks from a library. I will show you in a second what I mean. And it works by showing you very literally right out there on the graphics editor what the system is going to look like. The links represent physical phenomena that interact with each other. It has a comprehensive library of blocks ranging for different types of systems. You can simulate anything from including electrical circuits. You can simulate mechanical systems like spring mass system. You can simulate thermal systems like heat transfer systems. So it's very simple and intuitive, and for those who are not very programming savvy, if you will, it's very intuitive and friendly. So this is what the graphical interface of Simulink looks like. So here in the graphical editor area, it's where you drop your blocks and you make the connections. These individual blocks represent individual phenomena or processes, if you will. So for example, here I have an addition block. What this is telling you right now is to add the signal that comes from here and subtract the one that comes from here. And this is the gain block right here. And this one is a transfer function. And yeah, if you don't know any of this, don't be worried. We'll cover it in later videos. So this is what the graphical interface looks like. All I want to do in this video is show you how this is similar to Scilab's Xcos. And this is a library browser. You just search for whatever you need and out pops. And then you just drag this from here and drop it in the graphical editor area to start your simulation. Now, comparing Scilab and MATLAB. Like I said before, Scilab is open source, whereas MATLAB is paid proprietary software. So that's a major boost, especially for those who are not willing or maybe not able to pay that much money just to use MATLAB. Then Scilab is a very great alternative. And numerical computing capabilities, both Scilab and MATLAB provide powerful numerical computing capabilities, but if we compare their power by the accuracy, MATLAB probably offers more advanced simulation capabilities for complex systems. Obviously, it comes with more capabilities if it is paid. But that doesn't mean that Scilab is naive. Scilab, you can still do a lot of stuff with Scilab. For most of basic, especially for students out there, for most of your projects and for most of your simulation needs, Scilab is very capable and more than enough. And then syntax and functionality, their syntaxes are very similar. If you're already familiar to MATLAB, then you'll have no problem getting accustomed to Scilab's environment. Also, there is an extensive help browser in Scilab if you need help to show you the syntax and how it is similar to MATLAB. And toolbox availability. Both MATLAB and Scilab has very wide toolboxes, specialized toolboxes available. These are like Python libraries. These are equivalent to Python libraries in MATLAB and Scilab that are called toolboxes. For example, in Scilab, there is a specialized toolbox called Xcos for additional powerful simulation tools, in addition to the ones that come with the Xcos. We'll look at that later. And Scilab is actually a French product. It's made by a French company called Inria, as you can see here. And the reason Scilab is very similar to MATLAB is because it's meant to be. It's designed to be an alternative, a free alternative, open source alternative to MATLAB. And like I said before, this is all in French. I found it from one of their booklets on their websites. And they have a lot of researchers. They include, they have applications, receive applications for internships every year from many engineers and students out there. And it's a huge research group called Inria in France. They have made Scilab. So just wanted to show this. Now finally, let's talk about Xcos. Like I said before, Xcos is to Scilab what Simulink is to MATLAB. Xcos is Scilab's version of Simulink. It's a graphical editor just like before. like I showed you before, is the blocks and the links and the graphical area. Xcos is also Scilab's way to show graphical modeling. It's a graphical modeling and simulation tool for dynamic systems. It has a block-based approach, like you can see here. This, for example, is a step block. This is a summation block, and this is a transfer function. And there are stuff like a scope. This is a sink. You can edit the parameters in the sink to, edit the final view, the graph that you will get after the simulation is done. And Xcos provides advanced simulation capabilities for control and signal processing. So if you open Xcos, this is what the interface will look like. You will have your menu bar. This is the run button. After you're done with the blocks, you drag and drop the blocks from the library browser, similar to what you have in Simulink. For example, here I have a simple step function block, and here is the transfer function. If you're familiar with control engineering and engineering courses, then you know what this is. And here is a clock. The clock is what controls the simulation parameters. For example, the resolution of the simulation, how many points in time does the simulation cover. And the oscilloscope here will be the sink that receives the signal and displays the output graph. So this is what Xcos looks like. And if you compare Xcos and Simulink, you'll find that they're very similar. Both offer graphical modeling, and both have extensive block libraries for various uses. And the simulation performance is also great, and for everyday purposes, both Xcos and MATLAB will have very similar performance ratings. But if you're dealing with a line of work that requires very extreme efficiency, if you want it very fast, or if you're modeling very complex systems, then maybe you will go with MATLAB, because MATLAB has higher simulation performance compared to Xcos. But anyway, here's what the output window will look like after you run a simulation. This is, for example, this is two graphs plotted together on the same time axis. And you can see here there are various modes of the graphs. This one here is a solid line. This one here is a staircase, also called the echelon form of the graph. So yeah, there are many ways you can edit the graph after the simulation is done. So if you like this video, hit the likes button, and don't forget to ask any questions if there is anything unclear. Maybe add some comments if I forgot to mention something worthy of mentioning. Maybe something I got wrong even. Say what you have experienced before. Maybe you have some experience with Scilab, maybe you have some experience with MATLAB. And if you like this kind of video, tell me if I should do a second one. I already have Scilab. I've done some programs on Scilab, and I can do some tutorials. And if you like this kind of stuff, feel free to share and feel free to comment what you like. That's all.